Hey, hello everyone, my name is Miguel Hernandez, you can call me Mike. And today we're gonna solve a problem using Java, as you can see. We are using the platform codewars.com. And so let's get started. Here are the instructions. Your task is to make a function that can take any non-negative integer as an argument and return it with its digits in descending order. Essentially, rearrange the digits to create the highest possible number. And we have some examples here. So we have this number 21445, and the output is going to be 54421 because the 5 is the highest number here. So the highest number is always going to go to the right, and the lowest number here is number 1, so number 1 is going to go to the right. So as we can see here in the output, this number has its digits in descending order. The same is going to happen here, 145263. The highest number here is 6. So we have the 6 here in the first place. Then we have the 5. This is the second highest number. This is the output. So essentially the output is 654321. And in the final example, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9. The output is going to be these same numbers backward. So we have the output here is 9, 8, 7, 6, 5, 4, 3, 2, 1. So essentially, this is what we have to do. So let's get started. I already have the code here. If you ever used Code Wars before, you know that you can test this, and it's gonna say if your code is right or if your code is wrong based on the examples based on the sample tests we have here. So I'm gonna run my code right now. It says sending request. So as you can see, all the tests have been successfully passed. And so this is the code. I'm gonna start. First, I have to say I divided this problem in 4 sections. In the first sections, we're gonna get the number of digits of the num. Num is the input number, as you can see here. In the second section, I'm gonna create an array containing the digits of num. For example, let's say that we have number 15, it has 2 digits, so I have to create an array having two places, you know. And for example, if I have 9099, it could be an array with four places with 4 index. So this is the second sections. We have to create an array based on the input number. And section 3, we're gonna sort the array so that we get first the highest number and we got the lowest number in the end. And finally, in section 4, I'm gonna have to take this array and I'm gonna have to convert it into an int because that's what the problem is asking. It is not asking for an array, it is asking for an integer number backward. Okay, so these are the 4 sections. So first, get the number of digits. Second, create an array. Third, sorting the array. And fourth, creating the final number. Okay, so let's get started in the first section. We have 3 variables here. So we have temp, we have digit counter. Sorry, I'm gonna change this. Okay, and we have 10 mult equals 10. So the digit counter is gonna tell us how many digits we have in our number and the input number, and the 10 multiplier or 10 mult is gonna help us to count the digits. So we're gonna use 10 mult in order to increase digit counter. And in temp we're gonna store temporal variables. So I'm going to start with a do while loop. Here it says temp equals num divided by 10 mult. So I'm going to say this. and the result is equal 0, I mean if this operation is equal 0, then this variable 10 multiplier has more digits than the input number. For example, let's say that the input number is 9 and the 10 multiplier is, obviously we have now 10, so 9 divided by 10 is going to be 0 because we are working with integers. So if the input number it's not 9, let's say for example that it is 10, 11 or 12, if it's at least 10, we're gonna have 10 divided by 10, and 10 divided by 10 is going to be 1. So we know that if the result is 0, it means that the 10 multiplier is going to be a highest number than the input number. And since we know that the 10 multiplier is the lowest digit that has more digit, sorry, that the 10 multiplier is the lowest number that has more digits than the input number, so we use that in order to increase the digit counter. So let's say here, for example, we're going to check the sample test. Okay, so in the first test, this is going to be the input number. It's going to be 0. So the input number will be 0 here. So 0 divided by 10 is going to be 0. So if it's 0, then this is not going to happen, and the digit counter is going to stay in 1 because 0 is a one-digit number. So let's say that now that we have 51, or sorry, we have 15, the input number is going to be 15, and we will have 15 divided by 10. The result is going to be 1. Since 1 is higher than 0, we know now that we have a two-digit number. But we don't know how many digits it has. We only know that it has more than one digit. At least it has 2, but it could be 3, it could be 4, it could be 5, we don't know. So in order to know, we're gonna increase the digits of 10 mult. So in order to increase the digits, we're gonna multiply this by 10. You know, if we have original 10 as a number, it has 2 digits. Now, if I multiply 10 by 10, we're going to have 100, and 100 has 3 digits. And this is going to be a loop, and it's going to be working until 10 multiplier has more digits than the input number. So based on this, we can know how many digits have the input number. So now that we have the digit counter set as the number of digits in our number, in our input number, we have this, the int. We're going to create an array, we're going to create an array, an integer array, and we're going to use some variables after that. For example, here, what I'm doing is to use the mod function in order to get the last, the value of the least significant digit. For example, if I have 15, I need to get the 15. So I divide the number by 10. In this case, aux is going to be the input number. In the first, in the first iteration, aux is going to be the input number, like I say here. And if I make these operations, the mod, I'm gonna have the residual value of the divisions between, the divisions aux divided by 10. So 15 divided by 10 is gonna be 1, but the residual number is gonna be 5. So I'm gonna get the 5 in the last index of the array. Then I have to eliminate this 5. So in order to do so, I'm gonna divide aux by 10, and the result is gonna give me a 1-digit number. So now I'm gonna do the same operation, and aux is gonna be in the second iteration, aux is gonna be 1 because this is the value, and 1 divided by 10 is 0, but the residual value is going to be 1. So this number 1, I'm going to store it on the first index in the array. So now we're going to have an array with 2 digits, I mean 2 indexes. In the first index we're going to have 1, and in the second index we're going to have 5. Then I'm gonna just reset the variable, and finally, well, not finally actually, I'm gonna use the bubble sort method in order to sort the array. So this is basically what it's gonna do, is gonna compare each of the indexes of the array against the adjacent ones, and it's gonna sort it. So I'm not gonna talk about this. If you really want to know how this bubble sorting works, you can Google it. And after sorting the array, I'm just gonna sum up each of the values of the array by weighting them. So basically this is what we're gonna do. Let's say that, for example, we have this array 9, 3, 1. Okay, we can know this is already sorted, right? We have the highest value here and we have the lowest value here. So we know as humans that this is 931, but in the array it's just 3 different values. It is 9, it is 3, and it is 1. So we know that we can form this number by doing this. 931 is equals to 900 plus 30 plus 1. And this is the same that 9 multiplied by 100 plus 3 times 10 plus 1 times 1. And this is the same that 9 multiplied by 10, and this 10 is going to be to the power of 2, I mean squared, and then it's going to happen the same, 10 to the power of 1, and so on. So where do I get this? So where do I get this number from? This is going to be based on the digit counter. So let's say that, for example, the digit counter is 3, because in this example we know it's 3. So 1, 2, 3 digits. We're going to subtract 1 from that number, and this is the number 2, because we have 3 here minus 1, so we have 2. Then we have in the second digit we have the digit counter minus 2, and then the digit counter minus 3. So we see that in each one of these we're gonna subtract 1 to the digit number. So 2 minus 1 equals 1, and 1 minus 1 equals 0. And this is the formula we're going to use to calculate or to obtain the final number. So this is what I actually do. I use a for iteration for doing that. And this is it. In the first place, we're going to get the first. In the first iteration, we're going to get the first digit, and we're going to multiply it by whichever result has here. For example, in this case that we're using 15, this digit counter minus 1 minus I is going to give us the number 1. So we're going to obtain a 10, and in the second iterations we're gonna obtain this operation, digit counter minus 1 minus I, is going to give us a 0. So 10 to the 0 power is going to give us a number 1, and since we have a once it is sorted, we're going to have a number 1 in our last index is going to be 1 multiplied by 1. So the result is going to be 1. But in the previous iterations, we're going to have a 50. So 50 plus 1 is going to be 51. And 51 is going to be the result we're going to return. So I think this is really, really easy. You just need to think about it. And that would be all for now. As you can see, it is already working. If you want to get the code, you can download it from the link below in the description of the video. So that's all for now, and I hope you enjoyed. I think it was kind of difficult to explain for me, but I think it's really easy to understand if you have a look to the code. So see you later, guys.